Hi everybody, my name's Andrew McMurray. I am a technical evangelist for Windows infrastructure running out of Microsoft Australia. Welcome to the Hybrid Cloud Workloads High Availability and Disaster Recovery course. Hopefully you're going to get a whole lot of good information out of this course about how to look after disaster recovery and high availability in a hybrid cloud environment. So let's go straight into it with Module 1, Disaster Recovery in the Cloud with Hyper-V Recovery Manager. So, businesses looking to protect their workloads face a number of different challenges, and as with most aspects of the business, there are cost challenges. With business continuity, you need to balance the need to reduce downtime costs with the cost of investing in a disaster recovery solution. Some disaster recovery solutions with synchronous replication prove cost prohibitive to implement and are rarely used for more than a key applications. Another challenge comes from the constant monitoring of services. Monitoring your business continuity solution requires management software and training, and to maximise the protection of a business continuity solution, you really need some sort of remote data centre and remote monitoring, which further amplifies the costs. While simple solutions like failover clustering provide a small level of local protection and relatively simple recovery, more comprehensive solutions, especially those involving a remote secondary data centre, involve more complex recovery plans. The manual recovery of a service or a workload once it's failed can be extremely time-consuming and complex, and to do business continuity well requires constant testing to ensure procedures are up to date and that they work. Finally, businesses often must protect a wide variety of workloads, some of which are multi-tier or dependent upon several other infrastructure services such as DNS, Active Directory, etc. The result of this? Well, in most cases, this means only the most critical workloads get protected. Many applications that could benefit from protection go unprotected due to costs and complexity. So what's the best way for us to address these challenges? Microsoft Azure Hyper-V Recovery Manager protects applications by coordinating the replication of virtual machines at a secondary location. Microsoft Azure Hyper-V Recovery Manager brings together Hyper-V asynchronous virtual machine replication capabilities in Windows Server and the Virtual Machine Manager component of System Center, and combines them with the power of Microsoft Azure to provide site-to-site protection of your virtual machines in private clouds. This includes remote health monitoring and orchestrated recovery, so let's expand on these core functions. Hyper-V Recovery Manager provides three key functions: automated protection, continuous health monitoring, and orchestrated recovery. By integrating with existing established technologies that come with Windows Server 2012 and System Center, Hyper-V Recovery Manager can provide ongoing automated replication of virtual machines between two sites. It does this by using Hyper-V Replica and System Center Virtual Machine Manager 2012 R2. Hyper-V Recovery Manager configures replication options from the management portal, and once configured, the in-box technologies take over using your existing network. No workload data gets moved to Microsoft Azure or passes through it, and that's critical to understand. After configuring and setting up automated protection, Hyper-V Recovery Manager next monitors the virtual machines running within the cloud continuously with System Center Virtual Machine Manager. Hyper-V Recovery Manager only communicates with Virtual Machine Manager, looking at the state of the cloud and being ready to recover it in the event of a failure. The final function is to orchestrate the recovery of the virtual machines in the event of a failure in a timely and orderly manner. When recovering virtual machines in a System Center cloud, there is often a prescribed order that the virtual machines need to be started in to support the recovery of multi-tier services. A good example is first your infrastructure VMs have got to come up, then your database tier, then your web tier, etc., etc., etc. Hyper-V Recovery Manager enables you to create these customized plans and store them in Microsoft Azure. Plans also enable us to test the recovery process. It's always best to be prepared for a failure, and Hyper-V Recovery Manager makes it easy to test plans without disrupting running services, and then of course adjust those plans as necessary based on the results of the test. So let's step through how Hyper-V Recovery Manager works. So to use the service, the first step is to create a Microsoft Azure account and sign in. Once you've signed into the management portal, you can enable and then recover the service. There are a number of different configuration options that we can do here. And at a high level, the management portal configures the System Center Virtual Machine Manager server, which in turn configures individual VMs for replication and monitoring. Once you've created the recovery plans, we then store them in Microsoft Azure, and the replication and the monitoring begins. With health monitoring in place, you're protected against primary cloud or data center failure. In the event of a failure, Hyper-V Recovery Manager can orchestrate the recovery of the virtual machines according to the plan. But let's look more at the flexibility of the Hyper-V Recovery Manager configuration options first. Hyper-V Recovery Manager is configured from the Microsoft Azure Management Portal. Once you've created the Hyper-V Recovery Manager Vault, you can drill down into specific configuration options. We've mentioned it before, but one key feature is the ability to create and store recovery plans in Microsoft Azure. These can be customized to your needs and provide details on how virtual machine recovery will take place. You can also configure which clouds to protect. You may have more than one cloud in System Center Virtual Machine Manager, and Hyper-V Recovery Manager will enable you to choose the one you want to configure, or multiple ones if you need to configure all of them. You can configure customized mapping between virtual machine networks on source and target virtual machine manager servers, and network mapping is used during placement of a replica virtual machine. Replica virtual machines are placed on hosts which have access to the virtual machine networks, and when protection is enabled, the replica virtual machine connects to the virtual machine network. This ensures when the machine fails over, it is connected to the right network and is able to communicate effectively. Hyper-V Recovery Manager configures the System Center Virtual Machine Manager server, which configures Hyper-V Replica on the physical servers running Hyper-V, which host your individual VMs. This helps reduce the configuration and management you have to do manually on your own. You can also test these plans without disrupting service. Recovery plans can include elements like ordering a virtual machine startup, pauses, manual intervention steps, scripts, and pretty much any other action you can think of. Finally, you can monitor the service from the Microsoft Azure Management Portal, seeing exactly what is protected and how the service is working. So we've talked a lot about how the service communicates with your private cloud. Let's look at how this communication is kept secure. There are three key items that we want to talk about here. Firstly, only System Center Virtual Machine Manager communicates with Microsoft Azure. Your individual apps and your individual servers never talk to Microsoft Azure, nor does Microsoft Azure collect or store any workload data at all. That data doesn't even pass through Microsoft Azure. Second is support for proxies. If you want to use one, they're supported, and you only need to configure outbound HTTP from the System Center Virtual Machine Manager server. Finally, all communication between Microsoft Azure and the Virtual Machine Manager is encrypted. Part of the config process involves the use of certificates to identify servers and encrypt data. So we've talked about what Hyper-V Recovery Manager is, how it works, and the granular configuration that we have around that. So let's talk about when we might use it. So when considering Hyper-V Manager, there are some basic requirements. Because Hyper-V Recovery Manager can initiate and orchestrate site-to-site replication, you first need to have 2 sites available. Next, you need to be using or planning to use System Center Virtual Machine Manager 2012 or R2 and similarly recent versions of Hyper-V. Finally, if you have applications running in VMs that need protection, Hyper-V Recovery Manager might be right for you. There are some limitations. The replication itself is asynchronous, and this is coming from Hyper-V Replica as a feature of Windows Server 2012 Hyper-V. And while this is fine for many workloads, it is important to note. With Windows Server 2012 R2, we can adjust replication frequency to as often as 30 seconds to help mitigate this limitation. And when we were dealing with the original RTM version of Windows Server 2012, we were looking at every 5 minutes to 15 minutes. Workload data needs to live inside VHDs. That's absolutely critical as well. Hyper-V Recovery Manager can be highly beneficial to many organisations in protecting workloads that are going without protection today. And as we think about the business challenges from earlier, let's recap why you would choose Hyper-V Recovery Manager before we jump into a demo and show you what this looks like. So Hyper-V Recovery Manager addresses the challenges businesses face when looking to protect workloads. It automates the replication of virtual machines using out-of-the-box features from a central management portal. It provides continuous remote monitoring of services, and in the event of a failure of your private cloud, orchestrates the recovery of the workloads. Since Microsoft Azure Hyper-V Recovery Manager is easy to implement, it's also cost-effective. It's building on out-of-the-box features to provide a recovery solution, and these out-of-the-box features in Windows Server and System Center are designed to be easy to use, and Hyper-V Recovery Manager utilises those features, making it simple to set up and configure. We mentioned earlier that monitoring workloads can be challenging. The complexity and time-consuming nature of manual recovery services was a key factor in why organisations do not protect some workloads. And Hyper-V Recovery Manager provides remote monitoring of the applications and easy-to-use monitoring tools. The flexibility of the service is shown in the way you can create recovery plans to orchestrate the recovery of applications. Hyper-V Recovery Manager can then take care of the recovery process. The other reason to choose Hyper-V Recovery Manager is something that we've really not touched on yet. The service is built on Microsoft Azure. By building on the cloud service, the solution is capable of growing and scaling as you require it. So why don't we just jump straight into the Microsoft Azure Management Portal and have a look at how we would actually set this up and get it going. Okay, so in this demo, we're going to view the features of Hyper-V Recovery Manager and test using an unplanned failover. Now, as we've already mentioned, Hyper-V Recovery Manager is an Azure service that is your central console to manage and is the control plane for Hyper-V Replica for all of your sites. It orchestrates the process and the replication itself occurs point to point between your sites. So what we're going to do is click Recovery Services here. And as we can see, Recovery Services has been enabled for Contoso Corp. So once Recovery Service is enabled, the virtual machines are protected against a single location failure. So let's click on Contoso.corp now. And what we can see here is a dashboard showing the total virtual machines that are currently being protected and also any current jobs that have been run through the Hyper-V Replica system. Now, under the Protected Items section, I can review the sites I use for my Hyper-V recovery plans and I can verify that the virtual machines are fully protected. We'll click on Contoso Sales here for this particular section, and we can see under the replication status that all of the virtual machines are protected and okay. So now what we'll do is we'll configure settings for the replication. So the first thing we want to look at here is the copy frequency. Now under copy frequency, we can change how frequently the changes are being synchronized. In Windows Server 2012 R2, we extended Hyper-V Replica, so instead of only replicating every 5 minutes, we can now replicate every 15 minutes or every 30 seconds, depending on how critical the replication is and the mean time to restore it needs to be. What we can also do is we can create additional recovery points, and under additional recovery points we can configure multiple restore points for our environment, and if we elect to use additional recovery points, we can effectively increase the flexibility of our disaster recovery plan. Let's just scroll down a little bit, because one other interesting feature I want to show you here is that we can now do an offline transfer of our replicated data. And data compression is also available to minimize the bandwidth used during the transfer. So we'll leave those options as they are and just move back. Now let's have a look at the recovery plans themselves. So this is going to determine how we actually bring the VMs back online and what we do with the VMs in the event of a disaster. So we've got one recovery plan created for Contoso already. We'll click on that. And what we can see here is we have our all group shutdown and we've got our post failover steps here. And this is where we can automate recovery actions in the event of a shutdown or a failure. So what we can see here under our all group shutdown post failover steps is that we've grouped our servers into 4 groups, and this can be useful when we need to start specific servers first. And in this case, we'll start our database servers before starting any other virtual machines, and you can see those here. What we can also do is we can prepare a script for our failover steps, and you can see I have a script section here. Now let's go and edit this particular script, and what we can see is we can specify here a script that we're going to run after the failover, and what it's doing is it's calling a PowerShell script that's residing on the destination VMM server. We don't need to change that, so we'll just close it. Now let's have a look at the failover group. What we can also do in each group is we can add other actions. So we can, create new VMs, we can create new groups if we need to specify new groups of servers to do other things with, and we can also specify new scripts or even manual actions. So what I'll do here is I'll create a manual action to run after group 1 has come online, like so. And after the group 1 failover, we'll create a manual action to reset the physical network switch. So we'll put in our name here of reset switch. Our action instructions are to reset the switch to replica site. And note we've got options here as to when to perform this during test, planned or unplanned failover. And we've checked all of these. So basically what happens here is as the machines come up, an administrator is then told that they need to go and do this manual action. So we'll click check mark there and move on. Now that we've added that manual action, we can commit those changes by hitting save. And then we get the are you sure prompt, and look, I'm very sure of myself here. I definitely want to save that, so I'll click OK. And now we'll just go back to the recovery plans and simulate a failover. So we've got here our recovery plan. We are now going to fail it over like so. And with the recovery plan selected, we'll test using an unplanned failover. Now, the difference between an unplanned and a planned is a planned failover will automatically shut down the origin servers and reverse the replication. For unplanned, our origin servers may be down, so this is not an automatic step. So it still gives you the option as needed. So we'll go with an unplanned failover. So with this unplanned failover, we're going to switch our primary site from ws12 scvmm01.contoso.com to ws12 scvmm02.contoso.com. And this represents the two virtual machine manager servers in our data centers, which may reside in separate geographical locations. So we'll just shut those down and move on from there. Okay, so we've just seen how easy it is to orchestrate production and recovery of private clouds. And with Microsoft Azure Hyper-V Recovery Manager, it can help you protect important services by coordinating the replication and the recovery of System Center 2012 private clouds to a secondary location. So there you have it, Hyper-V Recovery Manager. If you want any more resources, just 3 on the slide for you to look at here. Check out TechNet Evaluation Center. Jump on there, download all of your eval software. Software lasts for up to about 180 days, depending on which one you've downloaded. Check it out. Or even try Windows Azure at no cost for up to 90 days as well. TechNet Virtual Labs, definitely want to have a look on here. You may not find one for Hyper-V Recovery Manager. It really depends on what time of the year you happen to be watching this particular video. Check it out. And then finally, MVA, the site you're on now. Plenty of free online technical courses. Have a look around, see what you like, and please remember to give us feedback. All right, so that was Module 1. We'll be right back with Module 2 and start looking at a little more to do with high availability and disaster recovery.